Okay, dependent and independent events. All right, this problem is going to take a little bit to explain. So I already wrote out a little bit of information here, which I'll explain in a little bit. But remember, dependent means that an event depends on a previous event. Independent means the two events that are happening, or three events, whatever it is, do not depend on each other. They're both separate events that are happening. So their outcomes are completely on their own. So here we have Jason has a bag that contains 8 identical shaped boxes. 6 of them are blue and 2 of them are green. So I did our blue in B's in blue and our G's in green. 3 of those blue boxes have prizes in it. So 3 have prizes. So for P for prize in pink, and 1 of the green boxes has a prize. So there we go. Jason randomly selects a box from a bag. Let A, so we're going to probability of A, be the event that he selects a box with a prize. So out of all our boxes in the bag, 4 of those boxes out of the 8 total have a prize, and that can be simplified to 1/2. So it's like a 50% chance of picking a box with a prize in it. Probability of B is the event that the box is green. So the box is green, that he goes in the bag and he selects a green box. It would be 2 out of 8, which is simplified to 1/4. Now we're not, these are not dependent on each other or anything. These are just 2 separate probabilities that we found. So obviously the 8 stays the same. Okay, so which of the following statements are true? So we're going to go through all these and pick the ones, choose all that apply. So some of your questions here are going to be choosing all the answers that apply. Now we want the probability of A given B, is that equal to the probability of A? The conditional probability that Jason selects a box with a prize, given that he chose a green box, is equal to the probability that Jason selects a box with a prize. Well, the probability of A here, in this case, is 1/2. Now here, that Jason selects a box with a prize, given that the box is green. So we have here 2 green boxes, and 1 of them has a prize. So it's like a 50-50 chance. So the probability of A given B here is also a 1/2. So yes, this would be true. We're going to just put a T here, letting us know that the probability of A given B is equal to the probability of A. The probability of B given A equals the probability of B. Well, we have the probability of B here is 1/4. So that's the probability that Jason will select a green box. So the conditional probability that Jason selects a green box, given that he has chosen a box with a prize, is equal to that. So green box that he chose a prize would also be 1 out of that 4. Okay, so because we have the 4 with the 4 of the boxes there that have a prize in it, and 1 of them is green. So that would also be true. Events A and B are independent. Yes, they are independent of each other because we're talking about boxes with prizes and then just green boxes. So that would be true. The outcomes of A and B are dependent on each other. Well, if we just told you that they were independent, they are not dependent on each other. So that is false. The probability of A and B equals the probability of A times B, the probability that Jason selects a box that contains a prize and is green is equal to the probability that Jason selects a box with a prize multiplied by the probability that he selects a green box. This would also be true because the probability that Jason selects a box that contains a prize and which is 1/2, and the box is green is 1/2. So, and then we have here which is 1/4. We have here the probability that Jason selects a box with a prize multiplied by that. So it would be 1/8. So we have 1/2 times 1/4 here is 1/8, and then 1/2 times 1/4 here is 1/8. So that would also be true. So our selections here would be A, B, C, and E. And we get it. All right, any questions? Let me know. Be careful with these. Make sure you read them, understand, reminder that we have unions and intersections possibility popping up in here, and that backward slash meaning subtraction. Okay, I'm here to help if you need me.